Example 26. Are there any questions about what it says before we get started? No? Okay. What's the mass of the car again?
0.25 kg.
What's the mass of the truck?
0.5 kg.
Okay.
Why don't you make two lists?
So I think I have everything. You make a car and a truck list? That's a good idea. Okay. So I think my picture serves as a decent list as long as I have my labels with cars and trucks in there. And we want to figure out if this collision is elastic or inelastic. So before I can figure out what's elastic or inelastic, what do I need to do first?
Calculate the final velocity of the truck.
Good, we got to find the final velocity of the truck. How am I going to do that?
That really long, annoying equation.
Momentum initially equals momentum final. So long and so annoying. Okay. So we have the momentum of the car, velocity of the car plus momentum of the truck. Velocity of the truck equals momentum of the car, velocity of the car plus momentum of the truck, velocity of the truck, right? Now, momentum is a vector, so direction matters. So which way do you guys want to go positive?
Right.
The right? Okay. So that makes the car's initial velocity positive, the truck's initial velocity negative. The car's final velocity is negative. Okay, so let's plug in what we know. 0.25 times 2 plus 0.5 times negative 4 equals 0.25 times 6 plus 0.5 times v. Right? Now we get to solve.
Is it negative 6?
Yes, thank you, Kyle.
Oh, I was going to say that, but I didn't want to be
Good
wrong.
catch, Kyle. So, 0.25 times 2 is 0.5. 0.5 times negative 4 is negative 2. 0.25 times negative 6 is...
Negative 1.2.
1.5? Plus 0.5v. Right? What should I do with this negative 1.5? And to the other side. Thank you. So we have 2 plus negative 2 equals 0. So 0 equals 0.5v.
The answer is always 0.
The answer is not always 0. So the final velocity of the truck is 0 meters per second. Does that make sense? Does that make sense?
Yes.
So there's no final velocity of the truck. It is stationary.
Is it? I had toothpaste in my pants and it doesn't look like toothpaste.
Goodness. All right. KE initial equals KE final if energy is conserved.
You didn't
and
square.
B squared.
I'm not there yet. I know, this is momentum. We don't square anything momentum. Okay? We use momentum here. Okay. So, I need to figure out my kinetic energy initial and final to see if energy is conserved. If energy is conserved, what type of collision is this? Elastic. If energy is not conserved, what type of collision is this?
Inelastic.
Inelastic. So, let's find our KE initials.
Wait, so how do you figure out if they're conserved, like, by the equation? Like, if they equal each other?
They have to equal each other. So, 1/2 mcvc squared initial plus 1/2 mtvt squared initial, right? Right? So we can plug in half of 0.25 times 2 squared plus half of 0.5 times negative 4 squared. Now I'm just going to take and erase the negative side because I know when I square negative becomes positive and I don't want to mess up my calculation. Right?
Oh my goodness.
Is that what you did?
No, I just got the answer.
Okay. So what's this equal? 7, really? I think you made that up. So 0.5 times 0.25 times 4 plus 0.5 times 0.5 times 4 squared. 4.5. Right? So that's KE initial. KE final is going to be 1/2 times 0.25 times negative 6 squared plus 1/2 times 0.5 times 0 squared. Well, this one's 0. Once again, I'm going to erase my negative sign again so I don't mess my calculation up. 0.5 times 0.25 times 6 squared.
How come you put 2 up there? Oh, that's a different one.
On the other side you get 4.
Equals 4.5. So what do we know about final initial?
It is that.
They're equal, right?
Yay!
Those two are equal. So since those two are equal, this is
Elastic.
Hey, Reg.
elastic.
Energy is gauzy.
You're out of nowhere.
Hey, it's Friday, not Thursday.
Friday. Okay.
Yeah, I misread it.